Yeah, so thank you again. So this is the talk I actually wanted to have. This is a little more about front-end development and okay, since there was no introduction, so I'm kind of maintaining a bundler that is not called Webpack, but still has some use. And have been doing so for 2 years. And if you want to know how to become maintainer of a bundler that is actually used, or basically any open source project that is actually used, it's really easy. Just do some pull requests, and if they're good, and let's say there's a 50% chance the person that is actually maintaining it no longer wants to maintain stuff, and suddenly you're the maintainer, and you notice it after a few months because there are no longer releases. And you think, oh, or maybe I'm the one who should be doing it now. And that's basically how it happened. And I assume most have heard about this. So Rollup.js is a bundler, has been so for years. So it's actually quite widely used by many big names, just not for front-end development. Because it's usually used for packaging the libraries for redistribution in Node, and there are good reasons for doing so. Still, I want to talk about front-end development. There's also some interesting project. Has anyone ever tried Stencil.js? Oh, cool, okay. Because if you have tried the command, the developer environment, basically you've been using Rollup all along because it's a really nice interface. So basically half the code base of Stencil.js is actually Rollup.js, and they managed to build something with hot module reloading, with ES modules. The first one to pull it off, as I'm aware of, and it's great stuff. And we had actually some fruitful conversations that resulted in a few new features. But what I want to talk about is this. And modern web development could be like this, but it isn't. So this is maybe like, let's go 10 years back. So you open up your browser, you write some code, you have, like, I don't know, 1, 2, 3 script tags, and then you see what happens. Okay, undefined is still not a function, so you change it, and in a second later, okay, cool, here it is. And I don't know who was programming 10 years ago. I must admit, I was not really doing web development at that time, but I had a computer and I had written a few lines of HTML. But something changed since then. And so if you go like to the present, web development looks more like this. So this is taken from a current project, and this is the number to look at. So this is like the time it takes when I started to, yes, I want to do development, and now my coffee is getting cold, but after 24 seconds I actually see something. And when I do a change, then it's a little faster. It's 10 to 15 seconds, and I see what the change brought. Probably made some mistakes, and you're getting careful. So, okay, let's do larger batches of changes, because really I want to do development and not want to sit here and have the feeling that 2/3 of my time I'm not doing anything. The question is, what happened? So, like 10 years ago, it was like, do something and we get the result. And today it's more like, I don't know, the machine or me, we are having some kind of battle of patience. Thing is, of course, JavaScript has gotten a little faster, projects got a little bigger, and it's not a cool idea to put a big project in a single file, at least not for humans, because humans tend to get lost in big files. So the question is now, okay, more things have happened the last 10 years. Since 2015, there is an official module system. So I could be writing different files, but still, isn't this module system, has been 4 years ago, isn't this kind of supported everywhere? So why am I not taking the next step and just use this module system as it's meant to be used in the browser? And this is basically what I want to show you, because I wouldn't do a presentation without live coding, so I'm doing some semi-live coding. And so what I've prepared here is basically a good old React application. It's slightly different from what you might be used to, basically, if you're looking at this one here. So this is where usually your JSX would go. This is a library called HTM, from which I get the HTML function. And the thing is, the syntax is basically identical to JSX, except that it's all template strings. And template strings are actually real JavaScript in contrast to JSX, which is not. So my browser has at least theoretically a chance of understanding this. And you also see I'm importing here React. Not importing it from React. Why am I not importing it from React? Because why should my browser know what React is? My browser only understands relative imports or maybe a really long absolute import starting with HTTPS or something. So what I'm doing here in shared.js is basically just re-exporting from my node modules folder here and here. And it's also, unfortunately, a sad story. This is not React I'm importing. This is a rebundled version of React by someone called Luke Jackson, really cool guy. He's basically doing everything the React people does, but leaves out the last step, which is converting everything to CommonJS. I don't know why they do it. React is completely written as ES modules, but at the last step, they just think, people want to run this in Node for some reason or something. And then we need to convert to CommonJS. And there is an open issue like 1.5 years maybe to finally provide an ES module build of React. And maybe in a year or so, there will be an official one. But until that, this one is, as far as I know, quite well maintained and should really publish new versions whenever a new React version comes out. So just have a little more look what you're about to see. So I got some run-of-the-mill counter component. This is using some hooks, so this is really React. I got a nice styling solution. This is also from Luke Jackson. It's called CSZ. Basics, again, template strings, and it's really lightweight. And you have nested styles, for instance. Here I have a count class, and which means basically every count that is inside my main class receives these styles. So I have here is where I'm applying the styles from above. So this is some namespace class, and the count down here will receive these styles. Really nice. And I think let's just have a look. As a development server, I'm also using another Luke Jackson. This is called Server, or actually it's Server, but running out of Unicode characters here. And what it does is really trivial. It's basically watching a folder. Whenever something changes in the folder, it's reloading my browser, and that's that. So and here's my application. I can do stuff. But of course, what's cool here is I was talking about the 21st seconds. So let's do some changes here. So this is, for instance, my title, and I'm typing and saving, and oops, and there is no delay at all. So you can just do what you want, or just, I don't know, change the color to green, and that's that. There is no wait, and why is there no wait? Because there's nothing happening in between. This is just the code that I have on my drive, pushed directly to the browser. So, oops, let's go back here. So of course, this is not perfect. So if you're putting this on a server and you're hoping for Google to give you a nice rating so that you're on the first page of the search results, you're probably out of luck. Why? Because your site will be kind of slow. So let's have a look what's happening actually when let's simulate we're in a really slow place, and let's reload this site here. And then it's like, so this was 4 seconds. Now I have a slightly high latency and also not the fastest connection. But the reason why this took so long is like this waterfall. You see the waterfall has basically 4 steps now. And the reason is, of course, I cannot start loading the app component after the index.js, and I cannot start loading the shared after the app, and I cannot start loading React after the shared. And if your application gets larger, this waterfall gets deeper and deeper. And to make things worse, something you don't see here is browsers really have a weird tendency to say 9 files at the same time. I think this is what Chrome does is enough. So it will not load 100 files at a time. It will load 9 files and then the next 9 files or something. So you can stand here watching. So this is not what you want on your server. So I'm maintaining a bundler. So we didn't see a bundler yet, so maybe we want to add a production build. So what are we going to do? So I added a rollup configuration. So basically the interesting part is all in those lines. The rest below, I'll have a few more words in a second. So I'm saying, okay, my index file is my input. My output should be, again, ES modules. This is the ESM, and I put this in a folder. So thing is, I also need to copy my HTML file because, of course, the location of the index.js is coded in the HTML file, and also got some styles. So I could, of course, add some bash script here, and all Windows users would be angry that I'm using a bash script or whatever, or I can just, what I'm doing here is using the plugin API of Rollup to copy a file. So a Rollup plugin is basically just an object containing some keys. This is generate bundle. This is called basically once a bundle is finished, but before anything is written to disk. And then I'm using a new file emission API, say, okay, I'm emitting two assets. The first is my index file, which I'm basically just reading from the index file. The other is my CSS file that I'm reading. And I'm also clearing the folder I'm looking at. And that's that. And let's just have a look what's happening here. And just run it again. Okay, so this is now the bundled version. And let's make this slow again. And no, this was 2.5 seconds. Of course, there are only, okay, actually there are 4 files. The 5th file is the React DevTools that are just kind of sneaking into every page. Okay, this is already much better. This is not perfect, but okay. 2.5 seconds instead of 4. So the thing is, it's still kind of suboptimal. So first thing is talking about DevTools here. Here the DevTools are red DevTools say what? It says that you're using the development build, of course. And that's probably not what you want. There is a production build of React, which is kind of faster. And to get a production build, we don't want to change the code we are writing. We don't want to taint our development experience. So everything we are doing is here in the config file. So we're adding something to our plugin. This is basically a mini resolver. Every module we load gets passed here. We just say whenever we import ESReact, we instead import ESReact production. So that's the production build. Then probably some minification. And also there's a nice Babel plugin for HTML, because of course you don't want to pass the template file, the template strings in your production build. Why would you? JSX is also compiled to React create elements. So there's a plugin that just set, compiles the template strings to React create elements. So basically you get the same performance as you would have if you had the traditional Webpack build with Babel and so on. For that, unfortunately, I need to restart because it will not pick up the changes here. And let's have another look now. And okay, so this was 1.3 seconds. I think this is better than 4 seconds. Also, in the previous screen, this was like 800 kilobytes. Now it's 130 kilobytes. And this is something really where you could do development here, and it would kind of work because it's still kind of small. I think it's half a second for rebuilds or something, but of course it get bigger. Actually tried out how big it can get, because this is the question, should I commit to this or shouldn't I? And I say, okay, there are limits. 1,000 files work okay. Chrome starts to crash around 4,000 files. Firefox is a little better. So they can even handle, 8,000 files. Didn't try more, because then it's also starting to get slow. But so this does work, and it has some potential, and usually you don't have so many small files. You would have small components, but 1,000 components you need a team to create 1,000 components, or a script. I was using a script, of course. Okay, so that's that. Going back. So just to recap, what did you see? Basically, this mostly stolen from Luke Jackson. It's full of Luke Jackson libraries. He got a repository, create ESReact app. Just he missed the last step of adding a production build. That's me. And also HTML is by Jason Miller. Jason Miller might be known as the person who created Preact, which is also a cool library. It's like React, just much smaller. And so Limitations. Basically, you've seen the most important ones. The libraries you need to use need to be ES modules. And this is true for many, but as you see in React, unfortunately, in its official version, is not. And there are quite a few others. I'm looking, for instance, at Material UI. It is written as TypeScript, I believe, but for some weird reason, they say we don't provide an ES module build because people might be using Webpack and then they have 2 versions of Material UI in the build and they cannot figure that out. Don't know. Create a pull request, create a fork. The other thing is you need to use relative imports, but there is a cool thing. Unfortunately, I only got it to work in Chrome and I need to patch my browser slightly. You must enable experimental built-in modules, which is import maps. So import maps is basically add another script tag at the top, type import map, and then say, whenever I'm importing ES React, instead I actually want to import node modules ES React index.js. And the cool thing is you don't have to even write those yourselves. There are tools that can basically get a package log file and create a complete import map out of the package log file. So if you look at my slides, like, I don't know, they are on GitHub. This is actually a link. You can't see this. You get the complete documentation for import maps and the surprisingly large amount of tooling already created for import maps.
How do the import maps fit into the production build?
In the development build. You would need to remove them for production. This is just to get the development experience like you are used to having it. Also, this would enable you to switch basically modules. So, I didn't talk about isomorphic yet, so this was part 1. Part 2, code splitting. So I'm told you 1,000 files, there is a limit. So if you have a lot of JavaScript code that needs to be loaded, the typical solution today is to use code splitting. Why? Because the idea is probably don't need the content of all those 1,000 files at the very first second. So maybe just load some bits later that you don't need at once, or just do it because it's so cool. And let's get back to our example and let's add some code splitting here. So where is my file? Ah, yes. So imagine I got a big component. I got a loader component for my big component, and basically I need to got a few applications running here, which are all really slow. So maybe change that. Okay, so this is not yet lazy at all. So imagine I got this nice component. When I click it, it's loading another component that's flying in. So what do you do to make it a lazy loading component? The official way for React is to use React Lazy, which looks basically like this. You replace the import with a dynamic import wrapped in a React Lazy. This is part 1. The other part is React Suspense. So where you use the component, you wrap it in a React Suspense, which is responsible for displaying some fallback text. And maybe I'm making it slow again. And what's happening now, you see the loading text, and here it is. And what you may or may not have noticed, probably not because it's the bottom of the screen, a new line appeared here with my code. So I'm just doing it again. And I can just basically clear it. And now when I'm loading here, the code of the component is lazily loaded later. And this is still just my setup from the beginning, so this is using what the browser already supports. Now when I go to my rollup build, the rollup build also has this component now, and it's also lazily loading it. Why? Because rollup knows that a dynamic import is probably the sign for lazy loading. You see, maybe something's changed here. Here's a new shared minus some hash file, which is the shared code between the dynamic import and the main entry point. I'll talk about this in a second. And when I'm clicking the component, you see there's a lazy component minus some hash. So the hashes are there because you probably want some cache busting anyway. You could also add the hash to the index.js, but then I cannot just copy my HTML file. Solvable problem, but I want to keep it simple. So the thing is, what did what did my rollup setup create? And when I'm looking at my lazy component something, then you see it's still a module. The imports have been rewritten to make minification a little easier, to be single letter imports. But other than that, and here's my Babel plugin from before, it's basically my lazy component as it was. So there is no added wrapper code or something. Why? Because, of course, I still got the ES modules, and the browser is doing all the handling that I need. So going to the presentation, so how does code splitting actually work? So this is a slightly more complex setup. So imagine I can have several static entry points. Those are the yellow and blue ones, and I got a dynamic entry point. So what rollup does is basically we're just starting a nice coloring game. So we're starting with the yellow entry point, coloring everything yellow that I can reach directly, except if it already has a color. And coloring in this case means I'm just assigning some hashes to the modules. And when I encounter a module I already have, I start mixing some hashes. In the end, this is basically the picture I get. So the yellow ones are the ones that I can only reach from entry A. The green ones from the dynamic entry, and the light blue ones, they are basically part of everything. And then I'm just merging them all into modules, and that's that. So the important point, of course, is that after the bundling, those are still modules. So basically, it's still kind of a drop-in replacement for what I had before. And this is the isomorphic part I was talking about. So it's not like back and front end isomorphic, but it's basically an isomorphism between bindings in the code. So every binding we have at the end corresponds to a binding we had in the beginning, so meaning variables. There might be a few more bindings in the beginning because it's removing dead code, so basically it's not really isomorphic. But the cool thing is you could even bundle it again, and it wouldn't get bigger, which is the big difference. For instance, if you do this with Webpack 10 times, you get 10 times the Webpack wrapper code. And this is also the reason why people are using rollup usually for libraries, because libraries kind of tend to add up. So if you have 10 libraries, as I said, that all contain like a Webpack build, then you have 10 times Webpack's code that resolves these things. And so how would this look in a traditional way? The thing is, how does Webpack know, for instance, how to get to these modules over here? What it does is basically it's putting all modules in tables and then adding some code to the static entry points. The code for the static entry points knows how to load stuff and how to look stuff up in tables. And when, I don't know, module 1 says we need to load the dynamic entry, then the runtime looks in the table, the dynamic entry is in the file over here. Then I'm loading the file. It's some kind of proprietary wrapper code. And this, of course, is nice because it kind of works, but it's also like it's the end point. You don't want to put any, or basically you cannot put stuff, any stuff on top of this. So, going back to nicer things, I've already showed you that writing plugins is not too difficult in Rollup. And as I'm basically mostly maintaining this myself at the moment, I hope for people to write plugins. So I'm rather invest time making this nice. So what you actually can do in a plugin is add new entry points. This is like emitting assets just with a different type. And why do you want to do this? So one thing is you get a reference ID, and then you can do stuff. For instance, you can ask Rollup, what is the actual file name for this emitted endpoint? And what you could do with this is, for instance, you could parse an HTML file, see, okay, I got these script tags. I'm creating chunks for those script tags. And then I'm replacing the place where I was doing the copying. I could also replace just the source attributes of the script tags with the actual generated chunks, and then I can have hashing for all the chunks, and I don't even need to configure it anymore because I can have 20, I don't know, chunks because I want to have, I don't know, some libraries split off because I don't expect them to change, and you don't have to configure anything at that point. Just have to write the plugin. I was a little lazy for this and didn't have enough time. Other thing is, if you want to go a little more advanced, you can also directly reference emitted chunks from the code. I don't know who's aware that import has an attribute.meta, which is basically a trash bin for attributes that you I don't know, global variables you want to reference. That cannot be overwritten. In this case, if you're in Rollup, you can basically add Rollup file URL reference ID in modules. And why would you want to do that? For instance, you're scanning the code for usages of the worker constructor. And what you could do is when you find a worker constructor, pick the file name, create a new chunk for the file, replace the file name with this, and then Rollup will put in a code that generates the file name in a way that should work after bundling. And last point, which may or may not be interesting, of course, is dynamic imports do not really work in older browsers very well. They only got supported in Firefox not too long ago. So if it's just dynamic import, that's a problem. That's really easy to fix. There's a nice polyfill. The only thing is you have to put an option to Rollup to say the dynamic import is called something else. And then you got that. If you need even older browsers, you can just switch the output format to System.js or AMD, but then, of course, you have to add a module loader and slightly modify your HTML file. But you can even do this automatically, though there is an example repository in Rollup that tells you how to do this. So this is the second part. For the third part, just a tiny glimpse what you're working on. So one thing you've already seen is that bundling or having a dynamic entry point created 3 chunks, which is a stupid idea. Why did it create three chunks? Because, of course, I got the yellow color for the entry, the green color here, and the difference chunk here. But, of course, I'm not stupid. I know that when the green one is loaded, the yellow one has loaded, so the light blue ones are loaded as well. So there's no reason splitting the yellow from the light blue ones. And this is something that will come really soon. So this is one request we're having, that we're creating too many chunks, and this is the main reason. I'm just hoping someone else does it because I want to get more people involved. So instead of fixing it, I wrote how you could fix it in the issue, and maybe someone will pick it up, unless I have too much time on my hands. Other thing that people keep requesting, it'll come probably, but in a far future, but it's kind of fancy stuff, is the question, okay, imagine I have 2 entry points and a shared file, and the entry points only use some stuff here. So the first entry point, is only using like the X definition and of course the console log, and the other entry point is using the Y. So I got this nice stuff. So what I could be doing is actually rip apart the third file and create these 3 files. So moving the X and the Y there, and just keep the side effect in the chunk. And if there was no side effect, I could even get rid of this file. So I've put some thought into this. This is definitely not trivial. Why? Because you have to really be careful that the order of the statements here is maintained after you rip it apart, because inside a file, it's really easy to have dependencies between lines. You define a variable here, you want to use it after you define it, not before you define it. And also require some bigger refactorings in Rollup, but this is something that will come eventually. And I think you'll not be able to get less code here, but you'll get definitely more chunks. So, as I said, I'm hoping for people to find this cool and want to join, like stuff you can do. The easiest thing actually is improved documentation, because really I don't know what people think of our documentation. I know this stuff, I don't need the documentation, but I heard that people like to read documentation. Or you can write plugins, or finding bugs is like, finding and fixing is okay. Okay, so just a little wrap up. So what you could have learned or not have learned, like in my vision, is that you don't need a build step, code splitting doesn't need a runtime, Rollup needs you, and that's that.